Hey, good morning. How's everybody?
We're doing good, Professor. How are you doing?
Very good, CFAD. How are you? Um, the connection is unusually slow this morning. I don't know, at least from my end. So uh, it took me some time to connect to Blackboard. But before I came in, I just checked the forum, and there were like 11 people that have signed in, and I see there are, well, I have like 14 people here. I have 14, right? So that means three people haven't signed in. Three people haven't signed into the discussion board. So if you haven't yet, uh, please do that ASAP. Now,
Good morning.
let me share my screen, and uh, okay, as of 11:05 a.m., I have 11 people. Why? Because it says 13, but 13 items. Two of them are mine, so that's 11. But there are like 14 people in the collaborate session.
Professor, are you
Yeah.
checking attendance right now?
Yeah. I mean, attendance is checked automatically. I'm not doing it right now, but what I'm telling you is, please don't forget to establish your a physical proof of attendance within the first 30 minutes. You know the rule. I give only the attendance reports made within the first 30 minutes will be recognized as present. Okay. So the first order of business, I made it very clear, and I don't know if this was emailed out yet or not, but if you go to the announcements, you would find this posting. This was posted actually today, September 1st. It clearly says the first order of business is to establish the physical proof of your attendance in the discussion board. So you must do this first before coming to the collaborate session. Okay, because the collaborate session is not the main lecture. And at the scheduled class time sharp, the scheduled dates discussion forum will open, where you must report attendance by creating your own discussion thread by stating your last name, comma, first name in the subject line. Okay, check out the instruction for today's lecture, follow and comply with the instruction. Okay, and collaborate session is not the main lecture, but rather like an afterglow for review and reflection on the main lecture and live Q&A. So collaborate session is for afterglow for live Q&A. Main lecture is delivered through the pre-assigned videos. So please make sure your microphone is muted unless you need to speak to prevent unnecessary background noise. All righty, so keep that in mind, that the first thing you need to do is to report attendance. Okay, because if it is missing, if your attendance report is missing, I wouldn't know if you were there. I mean, I would only go by, when I check attendance, I only go by the record, the physical record, right? And the physical record is this. This is the physical record, okay? All right. Now everyone, I believe everyone is here. That's like, 17 people.
At first, I couldn't hear you.
Oh, you couldn't hear me?
No, I think it was a bad connection on my side. Sorry about that.
Uh, my, okay, you might refresh your browser, or because my microphone is unmuted, right? Is that the same problem? Everybody else, how about everybody else? Can you hear me, everyone else?
Yeah, I can hear you
I
fine.
can hear you.
I can hear you fine.
Okay, all righty. All righty, thank you. Um,
It was just
now,
my side. I believe it was my Bluetooth headset. They died on me.
oh yeah, yeah, yeah. So, okay, so now, so without further ado, let me go back to where we left off last time. So, what we were talking about was there holding period return needs to be standardized, right? Because holding periods can vary between different investors, right? So it needs to be standardized. Um, and obviously, the best standardized unit for time is annual, okay? So we need to use annualized return. And you might think, oh, if my holding period is 10 years, then all I need to do is just simply divide it by 10. Simply divide my holding period return by 10. No, that is wrong. That is absolutely wrong. And I'm going to get to that. Um, uh, and one another thing that people generally don't clearly distinguish is that there is a difference between annual return and annualized return. But people generally just use it in confusion. They use it interchangeably, but technically there is a distinction. There is a difference between annual return and annualized return. Now, first, think about it. Annual return means, any annual data is that it's the data that already exists in annual form. So, like, data that was collected at the end of each year. That's annual data. But annualized means it wasn't originally in annual form, but you artificially annualized it. So, for example, you are holding this security. You are holding this security for only for 60 days. So you bought it, you bought it, today, and 60 days later you sold it. So over this, 60-day period, your return was 10%. Your return was 10%. 60 days is 2 months, right? Just to make it simple, 30 days. Let's say your holding period was 30 days. That's 1 month. So just over 1 month period, you made 10% return. Then you might think, oh, because I made 10% return for 1 month, over just 1 month, annually I should be making 10 times 12. No. Why? Because you never know. I mean, you just held it for 1 month, and you don't know what, because you already sold it. You don't know what might happen over the next 11 months. You cannot simply multiply it by 12. I mean, next month you may lose 10%. Another month you may lose additional 5%. And the next month you may regain like 5% or 15%. So in other words, we never know. So then how do you annualize in that case? Well, then you will need at least data for the last 5 years, for example, monthly returns data for the last 5 years. And it's not difficult because it's the past. It's what happened already last 5 years monthly returns. It's what happened already. So the data is already readily available. So you look at, then you will have like 60 data points, right? Including the most recent month where you had that asset. So you would have like 60 data points because it's 5 years. And then you can find the average of all those 60 monthly returns, and you can use that as the and then you compound it. If you found the average and monthly return, then you compound it by 12. In other words, you what you do is 1 plus that monthly average raised to the 12th power. That would be annual. And that is, and you might wonder why. Why is 1 plus that average raised to 12th power? That brings us to the next question. So I said, yeah, if annualized return means it's annual average, and then when we say average, because let's say over 10-year period, right? Over 10-year period, the holding period return over 10 years is let's say 200%. Then you might think, oh, if we annualize it, so annualization is simply the annual average. So if I divide that by 20, then it must be 10% each year. No, I said that's wrong. Why? Because it's actually, anything that grows over time already, has compounding built into it. It's, anything growing over time has compounding effect. So when there is a compounding going on, you can't use simple average. So let's go to the concept of a simple average versus a weighted average and geometric average. Now, simple average is what you understand as average. It's also called arithmetic average. And what is that? It's something when you take an average, what do? You add all the numbers, right? And divide it by the number of data points, right? It's also called number of observations. If you have 20 observations, that means 20 data points, right? And then you divide it by 20. But this is what you do when there is no time dimension between the data, right? Between the data points. So for example, if I want to take average height of the people in this class, right? What would I do? I will measure the heights of everyone in this class, right? There will be 25 people, and I sum it. I add up all the numbers and divide it by 25. And this is what I would do, because your heights are not correlated with each other. You understand? Everyone's height is an independent variable. Makes sense? They are not correlated. Your height doesn't depend on mine, right? And my height doesn't depend on yours. So, and the data is collected. All these data points are collected at the same point in time, right? Maybe a couple of days difference, but it's not like I took someone's height years ago and I took your height, someone's height today. I mean, there is no time difference. It's called synchronic. Everything is or static data. Static. In terms of time, it's static, right? The data were collected as static time. It's also called cross-sectional data, cross-sectional, because it's not the data collected over time, it's just data at the single point in time across the section, right? Across the entire section of this sample group. So cross-sectional data. And in that case, you can just simply add up, right? This means sum of all the xi's. I means individual data, right? I. So individual x, right? Individual x, where x runs from 1 through n, right? Of course, there must be first data point, second data point, right? 1, 2, 3, 4. And in this class, there are 25. So n will be 25. And you divide it by 25. And the opposite concept of simple average is weighted average. Okay? An opposite concept of a simple average is arithmetic average, right? We also, simple and arithmetic, they are the same. So you can, and the simple opposite concept of arithmetic average is geometric average. I mean, this is a little weird. I just did it that way because, there are two words, simple average and arithmetic average. But since simple average is arithmetic average, you can still say the opposite concept of simple average is geometric average. Then you might wonder, oh, then geometric average is the same thing as weighted average? No, no, no. Geometric average is simply a kind of one type of weighted average. It's time-weighted average, right? Geometric average is time-weighted average, but they are not exactly the same. Then what is weighted average? A good example of weighted average is your GPA. And I already did this in the main lecture video, so I'm not going to I'm not going to go over this. Please watch the main lecture video, right? But GPA is a good example of weighted average, right? Because not all of these courses are weighted the same, and the different weights are indicated clearly by the credits that they carry, right? And then when you, if you got, these, grades, then they are in numerical values, they are like this. And if you think, if I add them up and divide it by 4, then that's my GPA. No, no. Why? They have different weights, so you have to weight each of them by their credits. Their credits are weights, and then the weighted grade points are like this, and then some of that is like this. You divide it by total of those weights, and then that's your GPA. So that's weighted average. Okay. So then what is geometric average? So to answer that question, right? Now let's take a look at this example. So this is house value example. So let's say you bought a house at the end of 2005. Okay, you don't necessarily buy anything at the end of the year. You can buy it at any point. I mean, you can buy it in January or February, March. Any point in at any point in time during a year. But for the sake of our thought experiment, we assume that the house value was all measured. The value are all as of the end of the year, and I explained it in the previous previous sessions that house values are. I mean, any data, any price data, any data, it has to be as of the end of the time period because that's the conclusion. That's the conclusion of that, conclusion of that period, right? And I explained to you during the day, the stock market opens at 9:30 a.m., closes at 3:30 p.m., and there are four different price points: opening, high, low, and closing, right? And I told you, no matter how high, no matter how high during the day the price reached, or no matter how low during the day the price dropped, or wherever it opened at the opening of the trading, right? That all doesn't matter. It doesn't matter. What matters is the closing price of the day. Why? Because that's the conclusion of the day's trading. Conclusion of the day's trading. So if we collect the annual data of the house values, right? During 2005, it doesn't matter how high it reached or how low it fell. But at the end of the year, right? Where that house value stands, that's what matters, right? Because that's the conclusion of the house value for that year. So you may have bought the house at any point in time during 2005, but let's say for the simplicity, for the sake of the simplicity of our thought experiment, we'll assume you bought it at the end of the year. So that's the price you paid for the house. And over the course of 11 years, right? That's 11. It's going to be 11 years, from the end of 2005. End of 2005 is also the same thing as the beginning of 2006. You understand? So let's say end of 2016, the house value grew to 500,000. Of course, over the years, over the course of during the course of these 11 years, house values changed. Some years it went up, and then some years it went down. In 2007 there was a housing market crash, right? 2008 it went up, and then some years it remained. Some years there was no change. But so you want to know. You sold it at the end of 2016. Okay, you sold it at the end of 2016, and then your holding period was 11 years, right? 11 years. And the return is, of course, you can easily calculate. Return is simple. Without any cash, and what is this? This is in case you are renting out the house. If you rented out the house, but let's assume you didn't rent out the house in the initially. So in that case, what is the holding period return? It will be. Remember, price at time t plus n. This is the price at time t plus n minus price at time t, right? Divided by price at time t. And we don't consider this for now, right? We don't consider. So that means of this formula, right? This term dropped out because we didn't, consider this. Then this is pure, and if you do that, you would get 233%, which is purely the capital gains, return from capital gains, purely capital gains. And let's think about the capital gains. Capital gains are simply, literally, PT annually, right? Annually is this minus this, isn't that right? Between 2016, end of 2016 and end of 2015, right? So it's capital gains for 2016 during 2016, and it's the same thing here. So you don't. It's the same thing. In other words, the logic is the same. So you don't have to. You don't have to do it again. All you need to do is simply drag it down, right? You just copy, right? Copy and just drag it down. And here, what I did was I bring the cursor to the southeast corner. This is southeast corner of the cell, and you can tell the cell has the border line, but the border is broken. The border is broken here. In other words, there's a small square dot, right? Square dot. And if you bring the cursor right onto that square dot, then the cursor turns into a thin black cross. Normally, if you're hovering around, the cursor is the fat white cross. But sometimes it turns into a arrow-headed cross. Arrow-headed cross means you can drag it to somewhere. You can move it to somewhere else. You can move it to somewhere else. But we don't want to move it. We want the data to be there. And when you bring it to this point, it turns into a thin black cross. That means Excel is ready to copy and paste. So what you need to do is simply gently hold down the left mouse button and just drag it down. And you don't drag it down all the way down here, because there's no more data here, right? No further data, so you won't get anything. So then sum of all the capital gains is 350,000. This because I already entered this formula there. Sum from here to here, right? And then of course you can tell the sum of all the cash flows. You can tell also simply this minus this is also 350K. So either way, right? Sum of all these capital gains, or simply this minus this, right? It should still be, in other words, price 2016 P sub 2016 minus P sub 2005 should still be the same thing, right? 350K. Now, next question is, and of course, if you simply, so this is because this is capital gains. You divide capital gains by initial investment. It's still the same thing. You got to get to the same, right? That's the holding period return. Now, what is the next column? Next column is the additional income, and this additional income comes from renting. If you sublet it, right? Renting it out. So let's say this house was big enough for you, more than big enough for you. Let's say three-story building, with 8 rooms and 4 bathrooms, something like that. And obviously, this is if you live by yourself or if you live with your partner, it's still too big for you. I mean, you can use one floor, right? You can use the 3rd floor, and you can use 1 floor, but you can rent out other floors, right? So let's say you turn this house into an apartment. But of course, for the first couple of years, you need to you didn't rent it out. There was no subletting for the first couple of years. Why? Because you have to turn it into a, apartment building. So let's say you have to get permit from the housing department, and from the borough or from the city, township. You got to get the permit for changing it from just a single household family home into multiple household building. So getting all those permits and licenses and things like that, you have to meet also the building code. So there must be some renovations that need to be done to turn it into. So for the first couple of years, for the first 3 years, you couldn't rent it out. And then from the fourth year, you started to rent it out. And these are annual rents because we are dealing with annual data. So if it is annual rent, monthly, if the annual rent is, something like this, right? You can easily tell, oh, that was, monthly, that was, the rent was 15,000, 1,500. And then, from the, third year, you increase the rent by 10%. Here, well, you increase the rent to $2,000, and you can tell. So then, what's the sum of all the, I don't need to do, I can simply, drag it to, because this cell has, sum already built in there, I can just drag it to the right. Or I can also use auto sum here. That's auto sum. It's going to sum everything above that cell. So it's not that difficult. There you go. Oh, that's the then additional income, right? Cash flow. Then let's find out the holding period return with cash flow. Okay, with cash flow. Then, according to the formula, I will take the, difference between the two. And it was already done, right? The difference between the two is this one, right? Difference between, price 2016 and 2005 is already there, right? So I'll just use that. And plus this, right? Sum of all those income, bring that period. And then, right, you have to put them in parentheses. Otherwise, division will go first, right? You don't want that to happen. And then you divide it by the initial investment. And there you go. You have the holding period return with the cash flow is 347%, right? Okay. And there you go. It's the same thing. So why did I? So here, let's do it like this. B2 minus, right? B13, right? That's still the same thing, right? And then, let's think about then annual returns. First, this column E, is basically annual returns without any rent, right? Without any rental income, right? So our scenario one was, basically not subletting, right? You just use that house as your residence, right? That's it. In that case, there will be only capital gains or capital loss, right? Our scenario two is you use it as a rental property. Then there will be two components. There will be capital gains, and then there will be additional income, additional cash flow. So column E is the return in case of uh, scenario one. Under scenario one, what's the return? And why in that case is it not R but G? In that case, it's basically, growth rate. The return is only growth rate in your capital gains. G stands for growth rate, right? So it's not difficult. We already basically, then just like, holding period return, but in this case, holding period is just, 1 year every time, 1 year, year by year. Holding period is just 1 year every year, right? Then all you need to do is, oh, well, it's this minus this, or because that is already done, actually. All right, this minus this is this, capital gains. And then you divide it by the previous year's price because it's the growth over 1 year. And then you drag it down, okay? And this is going to automatically populate. Why? Because I already built in there, right? It's 1 plus G, so I did it there like that. And then column F is the return. So here's the difference between return and just the growth rate. Okay. So technically, return and growth rates are basically the same thing, but the difference is growth rate is the return where there is no additional cash flow, right? But if you think about it, if you acquire a financial asset, such as securities, right, stocks and bonds, right? If you buy financial assets like stocks and bonds, then there will be not only capital gains but also additional income. If you buy stocks, there will be dividends. Of course, dividend is not guaranteed, right? I've showed that. I've shown you the example of Apple. Apple didn't pay any dividends between 1995 and 2010. Over 15 years, they didn't pay any dividend. And growth companies don't pay dividends because they need to plow back everything into the growth. So they don't pay any dividends. So dividend is not an obligation. So the companies that are not growth firms, right, fast growing, right, companies that are not fast growing, what kind of companies are like that? Mature companies. Mature companies don't grow fast. They don't grow. They hardly grow. They are already mature. And mature companies generally pay out dividends because they don't, have room for growth. That doesn't mean mature companies cannot grow. I mean, it depends on, the mature companies can develop new areas of business, right? That doesn't mean geographic area. It can include geographic area, but also think about it. In this day and age, you cannot reach, any geographic. There's no geographic market you cannot reach, right? Over the internet, you can do, almost globally. You can do, marketing globally. But anyway, so developing a new market means, mostly not new geographic market, but more like a new venture. But anyway, mature companies pay dividends because they don't need to reinvest it for growth, because their growth potential, growth opportunities are quite limited. And then if they are just, and the investors will be demanding part of the company's earnings. So in the second scenario, right, we must consider the additional cash flow, right? Then annually, right? Now again, in case of stock, that additional income, additional cash flow is dividend. And in case of bonds, it's the coupon interest that the bond pays, and it's an obligation. Interest payment is an obligation. So annual return. Now this is annual return, not annual. So you can now see the difference between annualized return and annual return. So then what is it? So capital gains plus cash flow and divided by right, previous years. And if you see something like this, don't panic. Oh, I haven't done. Jesus, I didn't even divide it. It's not dollars. It's got to be percentage, right? And always use, by default, always use 2 decimal places. Don't leave it rounded. You must use 2 decimal places. And then the rest of it, you drag it down. Now, I'll explain to you why we shouldn't leave it rounded to an integer. Now, think about it. Leaving it rounded, if you leave it rounded, here's the thing. Here's the problem. Now, 1.49 and 0.51. Now, can you tell me these? What's the difference between these 2 numbers? Can anyone tell me the difference between these 2 numbers? Anyone? Come on, it's easy. Is there anyone?
1.01.
1.01? Is it that large? Is it greater than 1? I mean, if is yeah. Look, if it is 1.51, the difference will be 1. If this number is 1.51, then the difference is 1. Isn't that right?
That's correct.
Yeah. So look, it's not, the difference is not even difference is not greater than 1. It's not even 1, but the difference is then what? Difference between these 2 numbers. I mean, why is it so difficult? I mean, why? You can simply this minus this, K2 minus K3.
It's a 0.51 difference. No,
Uh-huh.
like the 0.9.
There's a difference.
Yeah.
Isn't that right?
No, there's no
That's
difference.
how it goes. It's 0.98. It's not 1, but it's almost as big as 1. The difference is almost as big as 1. Isn't that right? The difference is almost as big as 1. If the difference is almost big as 1, that means it's close to 100%, right? I mean, it's a whole one
Yes.
integer of 1. The difference is, almost close to the integer of 1. But suppose you leave this, if you leave this rounded, you leave it rounded. If you round it, it's gonna be, they are gonna be all 1. You understand? Now this thing isn't this thing, crazy? I mean, difference of 1, almost 1, is a huge difference, right? It's like difference between 1 and 2, and the difference between, if it is 2, think about it. That's like 200% and 100%. Difference between 200% and 100% is a significant difference, right? 100% difference is almost like, um, if there is 100% difference, they are completely 2 different things. Do you understand? But then you just carelessly, because you haven't been paying attention to things like this. But you leave it like, rounded, and then it could be the difference of this much. It could be the difference of almost 98%. So that's why you shouldn't leave it rounded to an integer. You must always give it at least 2 to 3 decimal places. Right? Okay, everyone gets that? That's the importance. Don't leave it rounded to an integer, although Excel is, by default set to round to an integer. But if you leave it rounded, then you will be making this type of mistake, right? As I said, 100% difference is like these two things are totally different, right? Okay, so always give it 2 decimal places, 2 to 3, at least 2 to 3. So here, okay, annually. Now, annually we have, these are the growth rates and returns. Of course, for the first 3 years, they are the same. Have you noticed? For the first 3 years, growth rate and returns are exactly the same, because for the first 3 years you didn't have any rental income, right? Then you might, okay, so if I annualize it, then isn't that simply the sum of, I'll do it here. Isn't that simply sum of all those numbers divided by 11, right? You might think, divided by 11, because actually in this case 10, wouldn't that be 10? Let me just make sure. That should be 11. Yeah, 11 rows, right? So I don't have to physically count it, because as I highlight it, you can tell. What do you see there? You see in this small box, in that small box, you see it says 11 rows by 1 column. 11 rows by 1 column. So I can visually check. I got 11 rows, 11 data points. Also, another way to confirm is when I look. What I did was instead of physically counting these numbers, how many data points there are, I use the count command. So as I highlight it, right, these data range, it automatically counts how many data points are there. So I don't have to bother with whether it is 11 or 10. So there you go. Okay, but then I told you this is simple average, and simple average is not right. But then but let's say for and because you don't know any better, let's say you did simple average. So do the same thing here. Oh, then the simple average looks like that. But then that's wrong. I told you this is wrong. Also, you can use average command. Average. That will give you simple average. It will just give you simple average. Or arithmetic average. But again, they are wrong. It's wrong. I took geometric average here. The geometric average is, why geometric average? Because geometric average factors in the effect of compounding. Compounding. So what is compounding? Compounding is like snowballing. So and here I also I could use geomean, but if you use geomean, geometric mean, geometric average, geometric mean, you would have to use 1 plus r. Or here, if I use that 1 plus this column, 1 plus g. So that's what I want to talk about. So now, so before I go to geometric average, right, let's take a 10-minute break and reconvene. Let's take a 10-minute break and reconvene at 12:05, 12:07, because it's 11:57. Okay, I need to give my vocal code. My voice is almost very hoarse. I got it. So 12:05, 12:07. Okay, let's take All right, we're back. We're back. I just noticed that in the chat box, Kenny Law dropped a message in the chat box, actually a question about the closing time of market. Yeah, it's 4 p.m. Somehow, market closes at 4 p.m. It's just that because I check, almost every day, around 4 p.m. What is the because I have my own holdings of my own portfolio, and some of the stocks that I'm watching. I'm always checking the price at around the closing time. It's 4 p.m. Future closes not quite sure exactly at what time. But, Kenny, thank you for pointing that out. I'm gonna give you a 0.25 points for mentioning that. Today is what? 0901, and this is section 1100, right? FNB 100, section 1100. So Kenny, you got 0.25 for that. Yeah, somehow, because of 9:30, somehow I thought it would be a whole number. So then the hours of operation must be in whole number. So then 4:30 must make it, exactly what 7 hours. But then 4:30 is too late. So I thought, was it 3:30? But anyway, yeah, 4 p.m. is when the market closes. Futures, I don't know. So if I go to and futures, this is NASDAQ and S&P 500. Let's just check NASDAQ today. Futures are up 0.6%. If this is by the hour, let's check by the hour, and then just for short range. Just by the hours. Oh, day? No. Oh, come on, by the hour. Let's do that. So 4 p.m. and then, after there's a trading, after hours trading, after hours, so the exchange is closed, but there is still after hours trading. So you see the data for even 7 p.m., 8 p.m. on August 31st, even 10 p.m. August 31st, 11. Then 12 a.m. to 8 doesn't mean the market is open, but the after hours trading is constantly, because it's online, you don't have to rely on. But I believe it is the closing of the day futures market 4:15. I'll have to check. But anyway, coming back to
Question, Professor.
yeah,
Does the closing does the closing period affect all nations around the world? Like all, like not all nations, well, like other regions around the world as well?
Oh, no, I mean it's not. So you're asking if there's a difference in the closing time of the stock exchange across the world, right?
Yes.
Yeah, I think it's not all 4 p.m. Some countries start at 9 a.m. Market opens at 9 a.m., not at 9:30. So then they may close at 3:30, right?
Right.
So
Due to
it's
the different due to the different time regions as well.
yeah, different time zones, but time zones are basically by the some countries have I believe India has like was it India or Pakistan, or they have like a 30-minute difference. I mean, usually the time zones are by the differences in hours, right? But uh, some countries have weird 30-minute uh, difference in time zone. The stupid thing is North Korea is on like 30 minutes behind South Korea, and basically South Korea and Japan have the same time zone, which is about 14 hours ahead of U.S. East Coast, 14 hours ahead of U.S. East Coast. Australia is the country that where the sun rises the earliest. Okay, you might wonder why. Does that mean Australia the sun rises at 4 a.m.? No, what I'm saying is the day begins the earliest. It's where the Australia is the country with the time. Australia and New Zealand, their time zone is the earliest in the world, and they are 1 hour ahead of uh, South Korea and Japan. So then, so they are like 15 hours ahead of U.S. East Coast, and then, but then North Korea should be on in the same time zone as South Korea and Japan, but somehow they are taking, they are anyway. They are odd guys, the odd man um, of the world. So, and they used to be using the same time zone as South Korea, but now they are like 30 minutes after, right? So they are like on that 30-minute different, the time zone with 30-minute difference from the regular time zones. So they are like one, and China is 1 hour behind Japan and South Korea and Japan, and so North Korea is somewhere in between South Korea and China. And then India, was it India? And a couple of countries have like 30-minute difference, and all the time zones are basically by the hour. Because think about it, the world, the whole entire world has, it's a globe. So every longitudinal lines, uh, uh, like if you divide 360 degrees by 24 hours, it's going to be 15 degrees. So by every 15 degrees, by every 15-degree difference, and the sun will hit the same 15-degree longitudinal line no matter where you are, right? So it cannot be yeah, you may, let's say you're not exactly lying on that no country lies exactly on the same longitudinal line. For example, Seoul and Tokyo are not lying on the same longitudinal um, line. So there can be, slight difference. But then, that difference within 15 degrees of the longitudinal lines, that shouldn't affect the daylights, significantly. But some countries have this little, um, uh, you know, um, idiosyncrasy or oddity. But anyway, yeah, some countries do have different opening and different closing time of the market, right? All righty. So was that Kenny that asked that question?
That was me. That was me, Jason Camacho.
Oh, Jason. Yeah, Jason. Okay, Jason. Yeah, they are. Yeah, not all the countries start at 9:30 and closes at 4 p.m. About 30-minute difference. It cannot be that much. Anyway, back to our. So here, so what is the geometric average? Well, to give you the first, let me give you the formula first, and let's talk about the steps of derivation. So the formula for geometric average is pt plus n over pt raised to 1 over n raised to the power of 1 over n minus 1. So that's basically growth rate. But also G, that stands for geometric average, right? And then let's think about why that is the case. So let's go back to our data, and then so now let's think about it. What is the price of 2006? Price of the 2006 can be expressed as price of 2005 plus 1 plus growth rate in 2006. Growth rate in 2006 is, for convenience, I wrote it as G1, growth rate in year one. Why? Now think about it. How did I get to this growth rate? This growth rate was simply this capital gains in 2006 divided by price in 2005. And what is capital gain? That's this minus this, right? This capital gains is this minus this. So this minus this, right? Divided by this, this is the growth rate. So that means, in other words, just consider this tooth. Let me rewrite it like this. I believe I wrote it somewhere, but let's rewrite it. So that means, P PT plus 1 minus PT divided by PT is G, right? Growth rate. But then if I rewrite it, right, it's going to be PT plus 1 minus PT. I'm writing, I'm actually drawing this thing with the mouse, so PT times G. Isn't it right? Right? We follow the math.
Yes.
And then how do I express PT plus 1? PT plus 1 is if I move, this PT to the other side, PT plus PT times G. And then, because PT is the common factor, right? If you factor out PT, then this becomes 1 plus, this becomes 1, this becomes just G, right? Times PT, right? Isn't it right? So we can express every next period price by PT times 1 plus G, right? That's the idea. Think about it. So, and that's what this is 1 plus G, right? So think about it. 2006. So 2006 price is basically 2005 price times 1 plus G1, growth rate in year 1, right? And you see why it is so, because it is PT plus 1 is 1 plus G times PT, right? So, and then 2007 price in 2007 is then price in 2006 times 1 plus growth rate in year 2, right? Year 2, which is the growth rate in 2006. I mean 2007, between 2006 and 2007. And then 2008 price is 2007 price times 1 plus growth rate of in year 3. Now, if you think about it, because 2006 price is this, right? I can simply replace this by the definition of what 2006 is, right? In other words, okay. So 2006 definition of 2006 is this. So I can substitute this by this, right? I can substitute this by this. And also 2008 price is the 2007 price times 1 plus G3, growth rate in year 3. I can replace it by the definition of what 2007 is. 2007 price is basically 2006 price times 1 plus G2. So replacing that, 2007 was replaced by its own definition, right? And then so this is 2007 price, right? Replaced by its own definition times 1 plus G. But then 2006 price is defined as 2005 price times 1 plus G. So if I replace it, then the whole thing becomes, so it becomes, right? This gets, replaced here. So then it becomes, basically every successive year, right, is, can be expressed as the previous year times 1 plus G for that growth rate for that year. So basically this 2008 price is complete, fully translated as 2005 price times 1 plus G1, right, which is 2006 price, times 1 plus G2, which is 2007 price, times 1 plus G3, which then is 2008 price. So now it's a tedious job, but if I continue to express it like that, 2016 price will be eventually 2005 price times 1 plus G1 times 1 plus G2 times 1 plus G3 all the way to times 1 plus G11, right? Now, you might wonder, why isn't it like, why didn't you start from 2006 and, come to, well, but, in math, this is the conclusion, and then you just simply add where you give, additional explanation after the conclusion, right? Where 2016 is the growth from 2015 price, right? It's 2015 times 1 plus G11, which is, which all reduces down to, which all traces back to 2005. So now, if that is the case, and that is explaining what is going on here. It's explaining what's going on here. It's basically explaining, think about it. If I try this, if I do this from 2005 price, if I multiply that by 1 plus this times 1 plus this times 1 plus times this times this times this times this times this times this, then you will arrive exactly at this, right? If you do that. So why? Because it is it's called compounding. It's called compounding. It's like snowball. Suppose you are standing on top of the snow-covered mountain, right? And then you make a snowball, which is originally a fist size of your fist, and then you drop it on the top of the mountain, and then it rolls down. Of course, it rolls down. As it rolls down, it gathers more snow, right? The snowball will grow because and it will, because the surface area gets bigger as it rolls down. The surface area gets bigger, and as the surface area gets bigger, the more snow will be added to the snowball. So in other words, at first, the amount of snow that gets added was small, but as it rolls down the hill, the amount of snow getting added to the snowball is getting bigger and bigger and bigger. In other words, it accelerates. It's not at the same rate.
It accumulates, pretty much,
it
right?
Accumulates. Accumulation, the rate of accumulation grows. You understand? The rate of accumulation is not even. It's not the same thing, because the surface area gets bigger. It picks up more snow. So the rate at which it's accumulating is accelerating as it rolls down the hill. You understand? It's not at the same 10% growth rate, the growth rate will get, bigger and go up. That's compounding, right? That's called compounding because it's if you look at the annual growth rate, each time they are all uneven. Of course, in think about it. In reality, nothing grows at an even rate, right? Even think about your own height. When you were until you were about 11, 12, you probably grew at of course between the age of 0 and 12, of course the growth rate each year was uneven. And even after 12, from 13 through 20, still the growth rate, annual growth rates would be uneven, but you would see, from 13, you may have the growth rates may shoot up. But, one thing is for sure, your growth rates in your height over your, if you are at least 20, over the last 20 years, obviously it's uneven. Nobody grows at an even rate. Every year, 2 inches. No, it's not like that. The growth rates are uneven. So that's why we take the average. But then when you take the average, it's not the simple average. We have to take the geometric average. Why? Because of this compounding effect. Because you are benefiting from the one particular year's growth rate, is benefiting from the growth. They are correlated, right? It's not independent. 2010 growth rate is correlated with all the previous year's growth rates. 2016 year's growth rate is correlated with all the previous year's growth rates. So there's a compounding going on here. You cannot simply take the, so when there is a growth, you have to take the geometric average, and the geometric average is the idea behind the geometric average is. So how do we take the average of this? Now, if you cannot just take the simple average, what do you need to do? So let's suppose there is one single average rate, right? One single average rate. If we have found, assume that we have found the average, and then that average will be something that will unify all these different growth rates because it's an average, right? In other words, we need in expressing PT plus N, for example, P 2016, we needed to write it as 1 plus G1 times 1 plus G2, 1 plus G3, G9, G10, G11. Because why? Why the subscripts there? Because they are all different. First year's growth rate is different from second year's growth rate, which is different from third year growth rate, and so on. But if we have found an average, then they will be all the same number. Isn't it right? If it is an average, right, we can replace all of these with that average. And let's call that average just G without any time subscript. Without any time subscript, right? Then everything will be, with that average, you arrive at the same result just by, replacing all of these by that G, the average growth rate. It will all, you will, starting from 2005, price of 2005, 1 plus G times 1 plus G times 1 plus G, so that G is the average, right? Then, the same 1 plus G 11 times, right? Same 1 plus G 11 times. And that's, that will get you to the same result as P 2016. It will get you to 2016. Then think about it. If there is no time subscript, there should, because it's average, it's all G, there doesn't need to be any time subscript. But then isn't that the same thing? I mean, 1 plus G times 1 plus G times 1 plus G times 1 plus G times, if you do it 11 times, can it not, can we not simply express it as 1 plus G raised to the 11th power, 1 plus G raised to the 11th power, right? It all boils down to, in other words, that means if for all time subscript, right? That means for all, where I is not equal to J, in other words, 1 and 2 are different, 2 and 3 are different, right? For different growth rates, for different times, right? Year 1, year 2, year 3, year 4. If those growth rates in those years are different, for all different years, right? That means for all different years, if growth in 1 year is equal to the growth in next year, that means you don't need time subscript, because if you have found a growth rate, an average growth rate, if you have found average growth rate, then we don't need to use the time subscript anymore, right? Because by replacing all of these by average growth rate G, then because it's the same thing, we don't need to use time subscript anymore. Then all of these terms simply collapse into PT times 1 plus G raised to 11, right? For our example, the price of the 11th year, price at the end of the 11th year is price at the beginning of the first year, right? Times 1 plus G raised to the 11th power. Yes, that's what it that's what it means. Basically, P price 2016 is price 2005 times 1 plus G raised to 11. It should be, and then based on. So think about it. Based on this, if you're solving this equation for G, if you solve this equation for G, and I'm gonna skip that because later there will be a time when we do time value of money, you will see how the steps of derivation, how you are going to open up this parenthesis, how we for now. The idea is what if we solve this equation for G? So if you solve that equation for G, that's how it is. We solve that equation for G. Starting from this, PT plus N, PT plus N is because PT plus N is PT times 1 plus G raised to N. So if you solve for G, then it will be this. So then what, with that in mind, this is what I did. Okay. I don't know if I put that formula in here somewhere, but there's another way of looking at it. But this is PT plus N, right? B2, what's in B2? That's PT plus N, right? Price in 2016 over PT, right? Raised to 1 over N. Why did I do this? I mean, isn't it 11? Yes, but instead of counting 11, I mean, instead of, physically counting 11, right? Physically counting 11, I simply did this. From 2016, if you 1 over this minus this will give you 11. Isn't it right? 2016 minus 2005, A2 minus A13 will give you automatically 11. I mean, This way, you don't have to manually enter anything. I wouldn't put 11 there because what if we know because 2016 minus 2005 is 11, but I don't want to do it even that at my discretion, right? Of course, it's at my discretion, but I don't want to do it like, I want minimum human intervention. The only thing that the human brain should do is just provide logic to the computer. I just provided the logic. I didn't enter any data there. The formula is basically the representation of the logic, right? Formula must be the representation of logic, not the you shouldn't enter any numerical data in the formula. I don't use any numerical data there because numerical data is there. A B2 is there. B13 is there already, right? And if you enter numerical data, then it is redundant. You already entered it. You took your time to enter it here. Why, double it? Why double that? Trouble. You took trouble entering this data there manually already. So other than the original initial data, nothing else should be entered manually. It should only be the logic that should be in the formula, right? That way, and then 1 raised to n, then minus 1. There you go, and I got that. So this is the geometric average. If I use and this one, I could have done the same thing, but I used the geometric mean for formula. It's not formula. It's the command in Excel. Excel has this geomean, and in that case you will have to use this 1 plus r. So if I use also geomean command, then I will have to use this. Now here it comes from this is the the idea behind it. And here, what can you tell? This is the true average growth rate, true average return, geometric. And you can tell simple average is actually overstating. Simple average is overstating that growth rate. Simple average is also overstating the return. So it's not the accurate one, okay? It's overblown in a way. It's overstated, right? These are simple averages are overstated when there's when there's a time dimension to it. Okay, so we are out of time. We're already 5 minutes past our class time, so I will have to dismiss the class. So take care, everyone, and I will see you guys on this Thursday. I mean, next. It's Wednesday, so
Next Monday.
No. Next Monday we don't have class. Okay, next Monday. So
okay.
whenever we meet again, I will see you then. We'll check the calendar. Okay.
Right.
Next week it will be like the whole week. We are we are on holidays. The entire week next week. So I will see you then. Take care. All right. All right.
All right. Thank you, Professor Hung.
You're welcome. Take care.
Have a good
Class
day, Professor.
dismissed. All right.
Thank
Class
you.
dismissed. Yeah, you're welcome.